Let us look at this question, which is a scholarship question on conic section. Okay, so the question says prove that any two perpendicular tangents to the parabola y squared is equal to 4ax cuts at a point on the directrix. So let me go over some basic facts that you should be knowing. Now this is a parabola defined by y squared is equal to 4ax. This is the focus, and directrix is a line which passes through negative a when focus is a. So here the equation of this line is x is equal to negative a. And focus and uh, directrix are opposite of the vertex. So this is the vertex. So focus is at point A, and directrix intersects the x-axis at negative a. Okay, so I'm not going into the definition. So if you take any arbitrary point on the parabola, the distance from the focus to that point is equal to the distance of that point from the directrix. In this figure it doesn't seem to be. Now just to explain, this is, as my drawing is not exact, suppose if you take P1 as a point, this distance, say this is say FP1 is equal to P1 whatever this point is. Suppose this is a point A. By definition, where this is the definition of parabola, that AP1 is equal to P1F. This is the definition of a parabola, and that's why directrix is very important. Okay, so that's not what the focus is. That's only the definition of the parabola. Okay, so basically if you want to draw it, this and this are equal. Okay, now I've drawn two. So this is point P1 at time t1. Okay, I'll come to that later, sorry. So this is your tangent L1 at P1, and this is your tangent L2 at P2, and these two are perpendicular to each other. That means they are right angle to each other, and we want to prove they intersect at the or intersect on the directrix. That's we want to prove. Okay, so what do we know? So let me write the parametric equation of a parabola. Parametric equation of parabola. The parametric equation is with the parameter t, time. So it is y is equal to 2at and x is equal to at squared. This is the parametric equation of a parabola. You can refer this in your formula sheet, and if you make t the subject, you will get this form. So this and this are the same. Okay, so here we can say at time t1 or at t1, you can say you get the point P1 which has the x coordinate of a t1 squared to a t1, and at time t2, so imagine a particle moving uh, in the path of the parabola. Okay, this is moving in a parabolic path. So when it is at time t1, you reach P1 point P1, and at time t2 it reach P2. So we can say P2, the coordinate would be a t2 squared comma 2a t2. Okay, it's a bit difficult. Okay, so what do we know? So these are the facts that we can say. L1 is perpendicular to L2, which implies L1 times the gradient. So let me write like this. So if two lines are perpendicular, the product of the gradients would be -1. So I can say ML1 times ML2 is -1. So these are the facts that we know. So let's write the parameter, sorry, the simple equation or the Cartesian equation. Y squared is equal to 4ax. So let us differentiate implicitly both sides. So you can say differentiating implicitly with respect to x, WRT stands for with respect to x. So I say, okay, dy dx of y squared is equal to 4a times dy dx of x. Now x, 4a is a constant, so you can take it out. You don't, this is only a coefficient. So this, I hope you know, this is 2y times dy by dx is equal to 4a, which implies dy by dx, the gradient of the function is 4a over 2y, over 2y. I can write that better, over 2y, and that can be simplified too. Therefore dy by dx, you divide, or you can factor out the 2, so that is 2a over y. So this is your gradient of the function at any point. Okay, so therefore you can say ml1, that means the gradient of L1. Therefore ml1 would be 2a over, what's the y coordinate of what at p1? It is 2a t1. The y coordinate is at L1 is 2a t1. It becomes 1 over t1. The same way, can I say m, or gradient of L2, is equal to 2a over 2a t2, which is 1 over t2. Now let me change color. Now we already know that m L1 times m L2 is -1, because the lines are perpendicular to each other. So therefore I can say 1 over t1 times 1 over t2 is -1. So if you do the reciprocal, the answer would remain the same. Therefore this is a very important result. T1 times t2 is -1. Okay, so in calculus questions, at times you don't know what you're doing, but you need to keep working. So basically, if you look at the question, they're telling you the point of intersection should be a point on the directrix. So in other words, you have to prove that the point of intersection is A, or -A, sorry. So let us write the equation of L1 and L2. We know the gradient of L1 and L2, so we can write the equation of L1. So let us write equation of L1. Okay, equation of any line is y is equal to mx plus c, where c is the y-intercept. So therefore I can say y, we know the gradient of L1 is 1 over t1x plus c, and I can substitute a point. I know a point on this line L1, which is at1 squared to at1. Okay, so I can put x. Now I can say x is 2at1 and sorry, where x is, the parametric equation is, your x is at1 squared and y is 2at1. So I can say x is at1 squared and y is 2at1. So let us substitute this. Let us substitute this in this equation. So in place of x I can put at1 squared, and in place of y I can put 2at1. So this becomes, change of color, 2at1 is equal to 1 over t1 times a t1 squared plus c. So 1 t1 will get cancelled and cancel t1, so what will remain? 2at1 is equal to at1 plus c, which implies your c is at1. Okay, so in calculus you should be ready to write in, think in abstract manner. So your equation is y is equal to 1 over t1, or x over t1 plus at1. So this is your equation. So this is equation of L1. So let me write L1, or equation of L1. Okay, so now equation of L2. Equation of L2, the same process. Y is equal to gradient, which is 1 over T1 x plus C. Now we know x is at2 squared and y is 2at1. So the same process will happen, and which implies you can write the same thing. Y is equal, I'm not going over the same thing, y would be x over t2 plus at2, which is your equation of L2. This is your equation of L2. Now at the point of intersection, or y is equal to this and y is equal to this, so I can compare this with this because they are intersecting. So, okay, now L1 intersects L2. That means there is a common point for both of them. Therefore I can say x over t, this should be t2, sorry, x over t1 plus at1 is equal to x over t2 plus at2. So let us simplify. Let's bring the x's together. So can I say x over t1 minus x over t2 is equal to at2 minus at1. Okay, so you can cross multiply. So this is t2x1, t2x minus t1x over t1 times t2 is equal to a times t2 minus t1. Now what is t2 minus t1? t2x t1 times t2 is -1. So can I write -1? Therefore, can I write x times t2 minus t1 over -1 is equal to a times t2, what has happened? So t2, yes, t2 minus t1. So what can you do? You got t2 minus t1 in the numerator and t2 minus t1 in the numerator. So you can cancel t2 minus t1. Therefore, I can say x is equal to -a. But what is x is equal to -a? That's nothing but the equation of the directrix. But x is equal to -a is the equation of directrix. Therefore, we can say L1, you can say L1 intersects L2 at x is equal to negative a. And that's what we want to prove, that they are intersecting on the directrix.